Hi, welcome back. In this video we're going to talk about power. So the first question is what is power in general, right? Because power in the context of electricity, before we get into it, what's power in general? So power is defined as work done by time taken, right? This can be illustrated with a simple example. Let's assume that you climb stairs in your 5-story apartment or 10 floor apartment. Let's say you climbed about 50 meters, that's about 5 meters per floor, and your mass is about 50 kg, and the force that's exerted by gravity is 10 meters per second square, and that's your weight. That's 500 Newton. Of course, the weight is a reaction force and all, but here we're calculating how much the earth pulls you, the force with which earth pulls you. So maybe it's more appropriate to write it as Fg, because your weight is a reaction force. So Fg is 500 Newton. So the work done is force into displacement. Again, work done is against gravity, and that's equal to 500 Newton into 50 meters. That amounts to 25,000 joules. So that's the work done. Now you can do this work in either 30 seconds, or you could do it in 5 minutes. If you do it in let's say for simplicity we say okay, it's number is fine. So for 30 seconds your power will be equal to 25,000 joules, which is the work done. The work done divided by the time, which is 30 seconds. That'll be equal to approximately, so the work done will be approximately about 833.3 watts. So just to give you a feeling of what this is, in your house, your electric geyser, your geyser is working effortlessly at an output of twice that you can do. So this is probably the best you can do. 10 floor 30 second is you have to be a really good athlete. In all probability you may take 50 seconds or maybe 1 minute or more, which would bring down your power by about 500 watts. So a geyser is about 1500 watts. A heater would be about 1000 watts. And what is interesting is after about 10 floors you will sweat and stop, but a geyser and heater will never sweat. It just keeps doing this for how many hours you may want it to do. So that's about power. So next, let's look at power in the context of current electricity. So in the context of electricity, you have two broad categories. One is as a producer. So as a producer, these are batteries, adapters, generator, etc. And then you have consumers, and your consumers are your fan, bulb, heater, geysers, which is like heater, but what else, tube, TV, refrigerator, etc., right? And so on. So these are your consumers. So now let's look at it from a producer point of view. In a DC, conventional DC, there is a gain of energy for a coulomb of charge, when you consider against a battery, and that's what you call as potential, you call it as potential gain. And let's say this is your V, and then a current I is flowing through this, or produced by V. So your power, your power produced is given by V into I. And it's quite evident if you look at it from units point of view. The V stands for joules per coulomb, into I stands for coulombs per second. So there you go, both of them go, and what you get is joules per second or watts. So that's from the context of the producer. The power produced is V into I. So let's mark it as a very important formulae that perceptively you can understand by thinking that I is coulombs per second and V is joules per coulomb. So as you multiply, you get watts. Now usually batteries are, if you take a AA battery, you will, it typically the power would be of the current would be of the range of 500 milliamperes, and let's say you're talking about a 1.5 volt battery. So this is about 1.5 volts. So the power output would be 1.5 into current would be 0.5. That's about 0.75 to 1 watts. So that's what a typical AA battery or AAA battery gives you. That's about 1 watt. Now if you look at fan, bulb and all these components, so this would be about 100 to 200 watts. And your heater is definitely a heavy duty stuff, and that may be close to 1000 watts. And your TV would be about, again, 100 to 200 watts. So it entirely depends on what you are using as a consumer, the amount of joules that you would consume every second. You can look at the equation for power from the consumer point of view as follows. So you have a resistor and there's a potential drop of V, and current I is being drawn, and that's R. And the relationship is your V is equal to IR. So let's start with the power loss is given by V into I, which is exactly the same as before, but in the context of battery that's the power produced, and here it's a power lost. Now this VI can be also written as V into I is V by R, so that's equal to V squared by R, and similarly it can also be written as I squared R. Let's wind this video with a small example. So let's assume that you have purchased a bulb from the market, and the bulb specification says that this is a 200 watt bulb and it has to be designed to operate at 240 volts. Now what that means is your voltage is 240 volts and this bulb can work in 240 volts, and the current that you're going to draw from your KEB or electricity board line is given by I is equal to power divided by the voltage, because P is IV. So that's about 200 divided by 240. So that will be about I of 0.833 amps. So that's what it'll be. So let's do one more example. So let's say you have 15 amperes, you're drawing a 15 amperes and you're putting your device, a geyser or something, against a 240 volts source. So the power output would be given by of the geyser would be 240 into 15 amps, and that will be equal to about 3,600 watts. So that's a huge power equipment. Usually your geysers would be of the order of about 2,000 watts. So you can imagine the current that would be drawn is not 15 amperes, maybe it'd be approximately 10 amperes, but this would flow through your 15 ampere line inside your house, which we'll talk about in the next video of household wiring. I hope you enjoyed this video. See you in the next one.